So previous class we were doing one problem of rank correlation. I hope everybody understood this problem where we took rank correlation of three judges, and once we find out the ranks of the judges, we were supposed to compare the rank correlations, that is 0.7334 and minus 0.2121 and minus 0.36996. So these are the three rank correlation of the judges. But out of the three values, if you observe the first two judges, that is RAB, Judge A and Judge B, that is positive in nature, and since it is a positive correlation, it is good and easy for us to consider for the conclusion. Okay, so we here rank correlation coefficient is maximum for judges A and B, and therefore we are supposed to consider them as the actual rank correlation coefficient, because that correlation is very nearest to the judge's approach and the taste or beauty. So that was the conclusion. Now going on further, merits of rank correlation coefficient. Okay, before I start this, did you people have any doubt in the previous question? Okay, so let us continue then. Merits of rank correlation coefficient. Now we have solved so many problems of rank correlation, Carl Pearson's rank correlation. Then we went on to solve Spearman rank correlation. Now both of them are there. Now let us see on a whole what is the merits of rank correlation. Firstly, it is easy to calculate and understand compared to Pearson's correlation method. Now without no assigning ranks, we were solving under Carl Pearson's correlation. But when you see the problems with assignment of ranks, after assigning ranks, it is very easy to calculate, because you'll just have to take the difference of the ranks and square the differences. That is the only next step you will be considering, or you will be doing it. So it is very easy to calculate and understand. Then when ranks are based on characteristics are given, it is the only method to be used. Now if you see the problems which we solved had ranks given in a beauty contest, or ranks given based on the intelligence, honesty. All these are qualitative in nature. So this rank correlation is the best method and is the only method where we can use to calculate the correlation coefficient. Then where the data are to be qualitative nature, like honesty, efficiency, intelligence, beauty, this method is of great use, because for these qualitative nature of data, there are no other methods except rank correlation. You cannot use Carl Pearson's correlation method, because you require, or they will give you a dependent and independent data to calculate. So for that, again, putting ranks or giving ranks will convert it into rank correlation coefficient. Next, these were the three merits of rank correlation. Next, we have demerits of rank correlation coefficient. Now, in the demerits, this method cannot be employed in a group data. Group data means if you have a class intervals, then ranking the class intervals is not possible, because you will have, say, suppose if the class interval is between 10 to 20, now you don't know which is the highest data there. Okay, so the rank cannot be properly assigned if it is a group data. Then this method is not useful in case of large quantities are to be ranked. Throughout the problems, we hardly had 10 to 12 data. So for 10 to 12 data, you can rank the coefficients, or you can rank the data given. But if the data is 100, 200, 500, then it takes, or it consumes a lot of time to do when you have too much quantity of data. So that is one of the demerit. But if the data is of qualitative in nature, there is no other go but to calculate rank correlation coefficient. Okay, so these are few merits and demerits of rank correlation. Any doubts in this? Okay, so going on further, now we have completed the correlation part, whatever we saw until now, that is completely done. Now the last part of this chapter and of your syllabus is regression analysis. Now once we are done with regressions, we have completed the syllabus part. Okay, so we will start with regression. I'll give you the introduction and everything today. Okay, so regression analysis. Now whenever you have same two variables, when in correlation we were having two variables, right? Now let's take for example age and sports. Okay, now if at young age many kids love to play a lot, as and when students, or as and when the kids grow up, they would they would get more lazy, they're not motivated to go and play. So the percentage of kids going out to play is very very less. Now if we take these two features as dependent and independent variable, I will also explain in clearly what is dependent and independent variable. So we can say these two factors are correlated. Now how can we say they are correlated? They should be interdependent. Now age is dependent on sports, and sports it's also dependent on age. Now age is dependent on sports. Now if you're young, people who are very young, no, they are very energetic to play any sort of sports or exercise. But people who are old, even though they are energetic, they will not be able to play very flexibly like young people. Maybe their body ailments or their age factor, so something or the other will come in between for them. So age dependent on sports, and sports dependent on age. Now you have under 19 cricket, under 19, under 14 football, volleyball, many games are there based on age. So even when they are having tournaments, they will have age wise tournaments also. So similarly, now what we are trying to understand here is, when the two factors are correlated, then the estimation of one variable given the value of other variable can be made. Now if I get one variable data, that is if I get the sports data, I can find out the age data. So the statistical tool with the help of which we are in position to estimate the unknown value of one variable from the known value of other variable. Now suppose we get the sports data, we will be able to find out, or at least estimate, the age of the kids playing in the tournament. So with the keeping the known data, we will be finding out the unknown data. So this is known as regression. Okay, so this is the bare understanding of it. Now we will see the statistical understanding in the coming slides. Okay, the dictionary meaning of the term regression is the act of returning back. Now returning back means you're coming back to the place and finishing the work and going like that. So, or stepping back, you step back and see what is happening, and then you go forward. Okay, so that is the dictionary meaning. But in statistics we don't use this meaning. So in statistics, regression is used to estimate the probable trend in a related variable. So here we can estimate what will happen to one of the variable, keeping the other variable in place. So we have only one variable data, so we'll keep that with us, and we will estimate the other variable data based on that, or based on the previous information whatever we got. Okay, so that is the bare meaning of regression analysis. Then a little history about the regression. The term regression was first used by British biometrician Sir Francis Galton towards the end of 19th century in a research paper. So always any sort of concepts that has been come to light is all because of the research papers. These people, biometricians, scientists, or mathematicians, statisticians, everybody, people who do a lot of research in one or the other, their uh, interest subject, they come out with a research paper. Now in this research paper they will explain everything about that particular concept, and if it is really valued, then it will be publicized throughout, and it will be implemented always. Okay, so this person is written in this research paper, Regression Towards Mediocrity and Heredity Stature, in which he presented the study on the relationship between height of fathers and sons. Okay, so this is what is the actual subject of the paper. He had published a research paper which actually spoke about regression, that is the relationship between the height of fathers and height of sons. So from there they started using uh, this regression analysis in many other places by using many other factors. Okay, so this is a little part of understanding of regression analysis. Any doubts in this slide? Now, going on further, to understand about few other definitions given by other statisticians uh, about regression analysis. Now, regression analysis is defined by Richmond. Okay, Richmond is a statistician. He has defined regression analysis as the technique for the derivation of an equation by which one of the variables, that is the dependent variables, may be estimated from the other variable, the independent variable. So which means in every in every regression you will have two variables, one is dependent, another one is independent. So dependent variable is something which is dependent on the other variable. If suppose let's take for example uh, this research paper which he gave out, height of fathers and sons. Now there are two variables, height of fathers and height of sons, right? Now what he was trying to say is dependent variable is height of sons. Okay, height of sons is dependent on height of father. So which means height of sons will become dependent variable, and height of father will become independent variable. So this one variable is dependent on the other, but this height of father can still work out without any other factor also. So that is one definition given by Richmond. One more definition which is given by M. Blair. Here he says regression analysis is the mathematical measure of the average relationship between two or more variables in terms of original units of data. So he's simply saying that it is a average relationship between two or more variables. So there's no too much of confusion here. He has put it into a very simple words. Okay. Now another statistician, Yo Lun Chu, okay, is a Chinese. So Chinese or someone from the Asian countries who has actually given a definition. Regression analysis attempts to establish the nature of relationship between the variables. It's very clear definition. Nature of relationship is being derived between the variables. That is to study the functional relationship between the variables. Now when I talk about height of father and height of son, I am creating a relationship between the height of father and son. So there is already one relation which is existing, that is father and son. Now I am also creating a relationship between the heights of both of them, and I am going to study them further. Okay, I'm going to make them as variable x and variable y, and I'm going to study on the further in-depth study on their height of father and height of son. Okay, and thereby provides the mechanism of predicting or forecasting. Now I will take a sample. Let's say I have taken a sample of 50 people, 50 fathers and 50 sons. I have taken the data, and I will come to a conclusion that the height of father is an independent factor, where height of sons is dependent on height of father. Now when I conclude using this 50 data, okay, I can also predict, I can also go on and predict further, saying usually or generally it is that height of father is um, influencing height of father is influencing the height of son. So that is also a best method. Okay, so this regression is also a best method for us to predict or forecast what is going to happen in the future place. Now this forecasting, you cannot say it is 100% right, but it is almost correct. So that is why this regression analysis is considered. Okay, so these are the definitions of regression analysis. Any doubts until here? So everybody understood and there's no doubt. So let us just quickly finish off this dependent and independent variable. This is very important while solving the problems of regression analysis. Another best example for regression usage is weather forecasting. So now you can see Bangalore has a little cloudy weather. That is because they say there is a depression which has happened in Bay of Bengal. Okay, so if Bay of Bengal has depression, then you will there is rains happening in Chennai, Kerala, and which affects a little part of Karnataka, that is Bangalore and all, towards this area, towards the little border of it. So this weather forecasting widely uses the regression analysis. Okay, they will have lot of softwares where this variables will be quantified. Variables is the clouds, the wind, direction, and how many kilometers per hour the wind is flowing, Okay, all this will be quantified. Okay, and then that software will be using this regression analysis, and it will be forecasting the data. This is also one of the tool where they will forecast how much rain will come, when the rain will come. Okay, all this is also used. Apart from this, there are many other softwares and tools which are used to forecast the data, but this is the basic and one of them which is used everywhere. Okay, so that's also one of the example. Then going on further, let us understand what is dependent variable and independent variable. So in regression analysis, you have two types of variables. First one is dependent variable. Now what is this dependent variable? It's one whose value is influenced by the other value. So this dependent variable always get influenced. Okay, so this dependent value is always getting influenced by the other variable. So in other words, variable which is to be estimated or predicted is known as dependent. So if you want to predict the weather of Bangalore, then you can say the dependent variable is the weather. Now, what is the independent other variables? You have many other factors to consider. So, what is to be estimated? I want to estimate rain. I want to estimate the temperature, day temperature of the place. So that is a dependent value. Then in regression analysis, the dependent variable is also known as regressed or explained or predicted variable. So suppose in the questions, if they ask, give you find the regressed variable, which means it is a dependent variable, or find explained variable. So explained means it is very clear that I wanted to know about the temperature in a daytime. So temperature in a daytime means there are many other factors which are dependent to increase the temperature, right? So it is clearly explained, and I want to predict the variable. So that is also been clear here. Then, so that is your dependent. Now going on further is your independent. The other variable type is independent variable. So here it is one which influences the value of the other related variable. So this will influence dependent variable. Okay, so this in short, to understand, let us take an example of uh, price and demand. Okay, when demand is high, when demand increases, price will also increase. Like your sanitizers, now demand of sanitizers have increased, so price of sanitizers have also increased. So that is, let's take them as two variable. Okay, so here what will happen is, independent variable is one which influences the variable of other related variables. In other words, the variable which is used for prediction. So we will take for example, uh, price is dependent on demand. So price is a dependent variable, demand is an independent variable. So demand is used for prediction. Now I will see until now how many sanitizers have been sold. Now from here on I will predict how much more demand can be there for the sanitizer bottles. So I am predicting very easily by keeping the independent variable. Okay, so in dependent variable also you will be able to do it, but a more clarity will be given from independent variable. So that is why it is called independent. It doesn't get influenced by anybody, it stays upright. Okay, so here this independent variable is also called as regressor, predicator, or explainer. Okay, regressor, here it is regressed, here it is regressor, here it is explained, here it is explainer, then here it is predicated, predicator. Okay, so these are dependent and independent variables. Okay, understood dependent and independent variables? Any doubt in this? Okay. So the next concept is regression lines. Now, regression lines means the device that is used for estimating the value of one variable from the value of other, which means we have one variable value. Keeping that one variable value, we will be able to, predict, or we will be able to estimate the value of other variable. So that is called, or that line where we will be able to find the values is called as line of regression. Okay, so in regression lines we have two types. First one is regression line of y on x, and one more regression line on x on y. So as usual, we will have a data of x and y together. Okay, x is one data, y is one data. So first we will take x on, sorry, y on x, where we will take one variable as dependent and other as independent. Suppose if we take y as dependent variable, x will be independent variable. Okay, this is scenario first. And scenario 2, again we will take same x and y, and we will interchange the places. Now x will become the dependent variable and y will become the independent variable. So when we do this activity, we will get a equations. You will get one equation here and you will get one equation here. Okay. Now, once we get these two equations, we are supposed to solve them simultaneously. Now, once we solve them simultaneously, we will be able to arrive at lot of values that is required to give a conclusion or to make a decision. So that is why we use this regression line y on x and x on y. Now let us understand what is that regression line of y on x and x on y. Now we will come back to this definition later. Now regression equation y on x. First one, we are talking about y on x. In this, what will happen is, it is used to describe variation in the values of y for the given changes in x, which means x values will be given to us. Okay, now once the x values are given to us, we will be able to predict or estimate the values of y. Since x values are given, we will be able to estimate the values of y. So that is why it is called regression equation x, sorry, y on x. So that is y on x value. Now let us understand y on x only completely. Okay, later we'll come for x on y. Now how do we calculate y on x? It is represented as the equation. Okay, so yc is equal to a plus bx. This is the main equation for y on x. See, we do not know the values of y, but we know the values of x. So keeping the values of x, we will be predicting, or will be calculating the value of y. So that is first equation, y on x. Then what does this notation stands for? Yc stands for value of y computed from the relation given for the value of x. A and b are the unknown parameters. So a and b here, whichever is given, are unknown parameters, where a is called as intercept. Okay, the a which is given here is called as intercept. Okay, and what does this intercept do is, it will help us to determine the level of balance of lines. Now this regression line is something like, in the graph, if you plot the numbers, okay, once you get all these, if you plot the numbers, you will get the regression either up like this. Okay, or in the same graph, if you plot the numbers, sorry for that. Okay, if you plot the numbers, you will get a regression line like this. Okay, so we have to make sure that these regression lines, whatever we are calculating, if it is correct or not, we have to understand and give the conclusion. So that is why we use all these equations, and we will be calculating the values directly, in which this A is called as intercept, and this intercept is going to determine the level of distance of the lines above and below the origin. Now if it is a positive value, it will go above the origin. So this is the origin, 0 is the origin. If it goes above, it goes above the origin. And then if it goes below the origin, okay, if it goes below here, that will be the minus values. Okay, so these are the minus values that will be below the origin. Okay, so that is why they are saying the distance, this is gonna measure the distance between above the line and below the line. Next, the value for B. Now B determines the slope of regression line. Now slope of regression line is, we'll be calculating the slope for this line. The positioning of this line is called as slope of the line. So B, we will be calculating that. So there are certain formulas which we will be learning when we go on with the problems. Okay, now after this, by solving the following two equations simultaneously, the values of A and B in the regression equation can be determined. Now if you see this equation here, A plus bx, okay, so this, in this A and B, we understood A is the intercept, B is the slope of the line. Now how do we calculate A and B? We will be having uh, two equations. Okay, we will have to derive two equations and solve them simultaneously. Now to derive two equations, what all we require? We require these values which you can see here. Okay, now once we solve this simultaneously, we will be able to get the value of A and B. So A is intercept, B is the slope of the regression line. Now once we are done with this, the let us see what all the values we require to calculate the equation. Now to calculate equation, firstly we require n. N will be the number of pairs of items in the observation. Then we want sigma x. Now they will give us the data x and y. So we'll have to add all the x data to get sigma x, and we should add all the y data to get sigma y. Okay, then after that we'll have to multiply x into y. Now once you multiply x into y and add them, you get summation xy. Okay, and after that you only require x square. So you have to square the values of x and you get summation x square. Clear? So that is sum of squares of value of x variables. You need not square y variables here. You have to square x variables. Why? Because we know all the value of x. We are doing the equation y on x, so we know all the variables of x, and we have to find out the y. So if you see, maximum of the places x has been concentrated more here. Okay, so now once we calculate all this from the given problem and we put them into this equations, then we will have to solve them simultaneously. Okay, so that is your regression equation y on x. Any doubt in this? Any doubt on y on x? Everybody understood? Okay, now what we'll do is we'll go to this problem. We will solve y on x first. Okay, so that, I think that will make it very clear for us how to we arrive at y on x value. And later, maybe next class, we will learn x on y and then complete the problem. Okay, so we will start with this problem. From the following data, obtain two regression equations. Okay, they're asking us both regression. Two regression equations means y on x and x on y. Both we are supposed to do. Now just now what we learned was y on x. So first we will do y on x. Now apart from that, what is the data given? They have given x, they have given y. Then hence predict y if x is equal to 5. So what we are solving first? Y on x we are solving, which means x value will be given and we have to find the y value. So only this data is relevant for us. That is predict y if x is equal to 5. Okay, this part of it we will solve it tomorrow. Now coming down to the table, formulation of regression equations. Now we have written down x values, however it is given to us. We have written down y values also. Okay, next going on further, we have to add up all the x values to get sigma x. Now if you see here, what are the important values? N, sigma x, sigma y, sigma xy, sigma x square. So sigma x is the first value. Okay, next sigma y or summation y is the next important value. Now after that we are supposed to multiply x and y and find out sigma xy. Okay, so first we added all x, then we added all y, then we multiplied x and y to get xy, and we added all that to get summation xy. Okay, next the other important value that we require is x square. Okay, this y square, why it is here, that is for the other part of it, so ignore this for now. So x square is what is required for our calculation of data. So x square, we are squaring this complete column here. We are squaring this complete column, and we also know what is sigma x square. Now, since we have all the important data with us, ignore this column. This is not required for now. Tomorrow we will learn that. Okay, so we have got all the required 4 data and the value of n 1, 2, 3, 4, 5. So n value will be 5. Okay, now let us go on. First is regression equation y on x, and the actual equation will be yc is equal to a plus bx, and we have to derive the two equations. Now two equations can be derived by this values, that is sigma y is equal to na plus b sigma x. The another equation is sigma xy is equal to a sigma x plus b sigma x square. Okay, now what is sigma y? Now sigma y is 40. So 40 is considered. Then 5a, we do not know what is a and b here. Okay, we have to find out. So n is 5. 5 is considered. Then sigma x. So what is the value of sigma x? 35. So 35b. 35b. So 40 is equal to 5a plus 35b. Next, second equation, sigma xy. What is sigma xy? 260. So 260 is equal to a sigma x. A is kept as it is. What is sigma x? 35. So 35a plus sigma x square. So what is the total of sigma x square? 275. So 275b. So these are the two equations which we have formed. Any doubt until here? Did you all understand how the equations are formed? You want me to explain it once again, or did you all understand? Clearly understand this chapter. It is very important from examination point of view, and also for any other topic in the further studies, you will have correlation and regression analysis being implied or used. Okay, so once we do this, we'll have to now solve these two equations simultaneously. Now to solve it simultaneously, we have to make any one of the variable equal. Either a has to be equal or b has to be equal. So